Alright, so yeah, like I said, welcome to my presentation for productive procedural pipelines using Houdini. So in this presentation, I'm going to be talking about two different topics, but first, let me introduce myself. I'm Erwin Heyms. I'm a technical artist at Ubisoft. I've been there for 8 years so far, and I've worked on Ghost Recon Wildlands, Breakpoint, and most recently on Riders Republic. And then next to that, I've been a Houdini teacher and mentor for the past 5 years. I started at Ubisoft. I made a 35-hour Houdini Core Masterclass, which was a video class, though it started actually as a lecture session in a classroom. And then more recently, over the past few years, I've been working on a new masterclass I call the Procedural Asset Production Masterclass. And this one is currently 40 hours available on YouTube. I'll share more about that later. Okay, so let's see. So the first thing that I'm going to talk about is about Ghost Recon Wildlands. I'll show some toolset examples about the production of Ghost Recon Wildlands, which was a large-scale AAA project which used extensive Houdini in its pipeline. And then next to that, I'm going to talk about my experience developing an interconnected Houdini masterclass. For starters, I will talk about an overview of the project itself, so the different components, and then I will demonstrate how its pipeline is put together. And then finally, I'll share some resources on how you can start training and learning Houdini for games or architecture. So here's a little overview, a little summary of the talk, and let's begin. Okay, so first let's talk about Ghost Recon Wildlands as a technical overview, right? So these slides are partially from Benoit's Hive presentation from 2019, just to preface that, but I've made some adjustments. Let's start off with a little video. Tell me if the volume is correct or too high.
Volume is okay.
Okay, so yeah, so the project that we worked on was a team size of about 300 people. In our technical artist team, we had 4 technical artists and we had about 2 engine programmers. Some were a bit of a mix between programming for the engine and regular programming, but the idea was that we had about 30 level artists between Paris, Bucharest, and Montpellier. And our goal was to make a large-scale production with a smaller team. We had about 200 digital assets, so Houdini tools, and well, we had almost 2 million render farm jobs that ran in the end. So kind of grasp the scale of how powerful Houdini was. Now, we had a lot of diversity in the game, about 11 completely different biomes, and each biome is made up out of several procedural layers, so lots of different styles. Next to that, the terrain was a 32K by 32K height field, and we had 4 different layers of editing. So it started out with World Machine, then we had a macro editing for like adding mountains and such by hand. Then we had the procedural layer, which the tools drove, and then finally we had a micro paint, which was more for local changes by artists after the procedural layer. Next to that, we had mostly natural environment, many forests, lots of trees, bushes, lots of rocks, deserts and such. So lots of instances for that. And we had about 600 kilometers of roads, so even more footpaths in the wild, and these were all generated, and they come with their specific dressing as well, so different biomes had different texture styles. And then we also had railroads. So we had a full railroad network going across the world, about 3 different train tracks that you can follow, and they intersected some locations. So there was quite a lot of rails. And about 16 kilometers or 16 square kilometers worth of lakes, rivers, and streams. So quite a lot of content there. Now, the way how we built this is we made the tools in Houdini, and then we would bring them into the editor using the Houdini engine. So us as technical artists would create our tools in Houdini, and then the artists could use them in Anvil, our game editor. Or we could send them to the render farm, but this was definitely not a runtime tool set. Right? The game couldn't handle that in real time. It was done during the creation of the game, not after. So then we had an augmented Houdini engine pipeline. So the Houdini engine allows you to run the tools in the game engine, but you still need to set up all the links. And our link setup was done through python.net. Basically, it allowed us to access the full .NET environment from a classic Python environment. We can load .NET assemblies such as binaries, DLLs, and X files, and then manipulate the .NET objects directly from Python. So we could communicate directly with the engine. We could communicate directly with Perforce and with any tools with the .NET wrapper or its interface. Mainly this is from the technical director, Guillaume Jobst. He set a lot of this up together with our engine programmer. Okay, so here's a little video for that. Basically, you can see how on the left we have our game engine. All the textures are currently just white, but on the right you have Houdini, and there's a one-on-one connection between the two through this .NET pipeline, and we could load in all the meshes and the models. We could see basically a preview inside of Houdini. Even the camera could be linked. So this is kind of like an early version of LiveLink. I'm not even sure if LiveLink existed at that point, at least not to my knowledge. So yeah, like I said, to set this type of advanced system up, you need a dedicated software artist to set up and maintain. Next to that, well, it expands the capabilities of the Houdini engine. And for us, that meant that we could import meshes live into Houdini, we could load terrain maps, and we could import instance data from the world. So very useful to have that to get started. And then in general, we generated about 80% of our natural world, even some of our man-made world, with Houdini. And then the rest of the 20% that was left was touch-up, but that basically meant that we could do an art pass over everything, and we had 80% of our resources left. So small team, big project. That's very important that you take as many of those tasks and make it the least amount of problems for you. So next, let's talk about the pipeline. I'm going to show you some examples. First, our procedural toolset had a large quantity of data that we had available. So some of the data that we could read was from our NAS, from our server, and this included height maps or other maps such as the material for the terrain, hand-painted layers, flow maps for water, for example, or sunlight exposure. And we could just access that. Next to that, we also had data from our game engine, such as instances and meshes that we could load in, and these could be retrieved as, say, point caches, like that, from our big file. And this came directly from the game engine, from the editor. So, yeah, this data was then used by a large range of tools. We could retrieve this information directly from the NAS or the big file, process it, write it back, and then output it to new data. So this created a versatile snapshot of our game world that we could access or that our games could use. For example, we could create splines for road traffic, spawners for events in the game, or even define sound zones for wind or echo in the mountains, right? And then we would composite our data so it could be efficiently loaded. Because we had several tools, they had to work together, and we needed to compress this data down into maybe 1 or 2 sets of data. So we would composite our textures together for the different tools for the terraforming, for the terrain. So we had our height field textures. They were basically compiled together into 1024 composite textures or texture sets. And then we did the same thing for the props, which were checked for proximity, overlap, and if they needed to terraform the area. And they had a priority, so certain objects would remove others, right? So we wouldn't have a tree inside of a rock or something. And those were tiled into about 256 tiles. So toolset that I want to focus on here is the road generator, because it's one of the first procedural tools that I personally built. It's one of the major tools in the production. And it allowed us to procedurally generate over 600 kilometers of roads at various sizes, different materials. It included road propsing as a added layer after, and we could also terraform it for the entire world. So up top we have our base terrain, and then this is what you would get if you drop the roads on it after the tool is done. Now the road tool itself was divided into 64 2x2 kilometer tiles. It would generate pathfinding, a pathfinding grid from the terrain. You can see a little bit of that with things for bridges, over water. It would deal with slopes, and then it would connect at the borders of each tile. Next to that, we could then use waypoints to draw paths in between, say, point A and B, and it would build a road between those. And then we would finally combine all of these tiles together into a main world grid, process it for curvature and intersections, and then finally output it to a terraforming mask. Here's a little video about that, where you can see you have two waypoints and it's pathing between them. We had control over how many turns it should make, trying to go up a mountain. And then next to that, there was also a priority. So we had our railways first, then larger roads, then medium roads, smaller roads, and finally we added on the villages, which could detect the roads. So quite a lot of vehicle AI paths as well with that. So the first step is to make a 2x2 kilometer tile, basically, to draw the waypoints. And then next to that, we could also create these bridge guides. So if you didn't have the grid for, say, a bridge, you could add one. And we could also add an exclusion zone if we didn't want the Pathfinder to find its way through someone's town or something. Like if they don't want to have a road somewhere, we could exclude it from there. And it would just find its way around. So the way it worked, once the Pathfinder was done, we would get this raw curve. We would then smooth out the curve at the turns and maybe some of these intersections on steep areas, so it wouldn't overlap too much going up and down. And then we could flatten the intersections where necessary, so you have better transition in uneven terrain. We could widen out the sharp turns, create these switchbacks. That's important for vehicles because they need to have a certain turning radius and they can't do it on a slope. And then finally, we turn it into a ribbon of sorts based on the width of the road, and we could then prepare it for terraforming. So all this data was then output to road curves, so the entire world network of roads was output to a single file. And next to that, we could take that and per tile also turn into a terraforming stamp, which we could then render out into terraforming textures. So we have our height map, and then we had a mask, the blue one, and then the pink-green channel actually was used for material values. So we combined that with all the other tools in the final step, which is the compositor. The compositor was necessary to make sure that we could actually make all these tools work together if they overlapped in some way, and we had quite a lot of that. So we had our roads, railroads, the villages, fields, rivers, and that would eventually basically be brought into this set: height, blending, and material. So as for the road tool, we actually had two versions. And the first version used this setup, where on the left we had the input tools. We had one for the waypoints, the bridge guides, and the exclusion curve. And then we could send a job to the render farm to compute out the pathing itself. So you have the dark green lines here that are the waypoints, and then the light green line is the path that it would find between those. And the circles are basically how far it can search for each path. However, then you would confirm if it was okay, if you liked it, and if you did, then you could send it for the compositing system to bring it all together in the world and turn it into terraforming textures. And then finally, we'd run the compositor to deal with the compositing of all the terrain layers. Let me drink something here. Okay, so this system was effective, but a bit cumbersome. Basically, users could provide waypoints, but we couldn't fully predict the paths they created. And if terrain, obstacles, or other factors were to change, then the grid would change and the pathfinding would be different and the roads could shift. And, well, designers didn't really like it if a road suddenly lay 2 meters to the right in the middle of their house or something. So as a result, the version 1 was hard to use for your average artist. Instead, it was managed by me and other trained artists as well. So mainly TAs and trained artists. Then I created version 2. In this case, I took the road finding, the pathfinding component, and I moved it into the input tool. And instead of computing the grid during the pathfinding process, I actually computed it beforehand. So first I would take the terrain, I would compute out the grid for the terrain and save it to caches. Then we could load that into the editing tool, create our waypoints, and it would give immediate feedback on where the roads would be because the pathfinding was done on the spot for those waypoints. Then you can save it out to a cache, and if you're happy with it, you can send it to the render farm for a quick render. It takes about 30 seconds to give you a basic idea of what it will look like. And if you're happy with the final layout, then you send it to the render farm for the final terraforming and compositing. And the other benefit was you could add and remove sections. I'll show that in a second. So version 2, like I said, took the Pathfinder. And the benefit of this was it was a lot easier to use, and you got the desired terraforming results in minutes, and it was much more predictable because you wouldn't have it shift on you. Because you're basically using fixed data. Even the roads, once they were built, were fixed. So with this, you could theoretically rebuild the entire world's road network in less than 2 weeks. Plus, it was much more artist friendly, so if artists needed to use it, they could. So like I said, here's a little video. So here is the view in the world with the preview. That comes from the actual computation of the road. But here's the editor. So we can select the tile and then select what type of road we want to build. Just place 2 waypoints and it will path between them. We can change the settings if it should snap to an existing road nearby or find its own way. Add new sections, save them out. And then if there is a section that you don't like here, you can either select it by number, or you could draw 2 waypoints, and then in between it will select it and you can then remove it. And then you can just add a new section in there. Next to that, we can also change the type of road. So we can select the section of the road, replace it, make it wider or smaller, add new pieces. So it was all pretty flexible. And then once we're done with that, we just had to send it to the render farm. So there was just a button on the tool. You click on it and it will trigger the render farm, tell it to render out a preview. And if you're happy with that, you can then send it out to the render farm to build your compositing, to build the terraforming. So as for the render farm itself, so we use the system called HQ, which is a system from Houdini actually. It allows you to set up tasks. And we had a program called World Batch to drive it. So we could use that to schedule or cook tasks on demand for any tools or combination of tools. We could then offload this computation to a distributed render environment of about 20 render machines. They were all running Houdini Engine licenses. And then, well, you may have noticed before that I sent it to the render farm, right? So this was very quick. It's very user-friendly because at that point you don't have to worry about it rendering on your own machine. You just send it out. A few minutes later, you get a message, it's done, and you get it back. Or you snap it into the world if you send out a render task for the terraforming. So next to that, we had our road networks. So the road network curves were sent to the NOS, the server, and from this we could then run other tools because they could load that data. So we had our road decals, for example, roadside propsing, vehicle AI, splines for the vehicles would be in there. Bridges would know where they could snap to the road, so they were correctly positioned. And we could even use it to generate our in-game map in the end. So lots of that. Now this I'm going to skip through a little bit faster, but we had our railroad and streams. They used pathfinding as well, and they could use this metadata as well. So we had our railroads, which had much bigger sweeping turns. They couldn't turn very quickly, right? And then we had our rivers, which would go down the mountains, going from the top of the mountain down to bodies of water, which creates a much more logical and historical priority, which creates much more like natural environment, I think. It actually feels like there's history to the world. Then we had the village toolset, another big toolset. This one hooks into the roads if they're nearby. They're generated from a center point, the town center, and then they have these distinct zones that you can define for the town center, high density, low density, and farms as well, or outer zones basically. And then it would place these props called smart props, basically structures with AI activities on them and other information. And then finally, it would also draw roads and paths for the civilian AI, so lots of that. And then over time, the toolset got scaled up and expanded, so we created cities. This one here is called Barvechos. It's one of our largest settlements in the game. And it contained new types of road patterns for grid patterns here. We had new layouts of buildings, such as these aligned buildings you might see, some of them there. And other features such as sidewalks and user-drawn districts, right? So we had a market district, Santa Blanca, enemy district, warehouse district, and so forth. And then using this tool, we were able to regenerate this particular town 5 times over the course of development. So we had about 58 settlements in total, and they were built in less than a month by me and one other trained artist. So we went from this to that. Well, after we did an art pass, basically, because we started out with this result from the tool, then we do the art pass, and then we have our final towns. Here's a little video on how the tool works, where we could place our point. It would create these zones, right, with roads. That would then allow us to specify little zones in between. And if I continue here, we have these strings of data, which basically described a building with its rule set. We could edit that down below here. And then from there, it would place these buildings in priority. So we have the church, maybe the market, train station. And then after that, we had a filler layer of smaller buildings like houses and little market stalls that would then be placed everywhere else. Next to that, it generated some footpaths, little walls for houses or something. And we could then stamp it into the terrain. Plus, it automatically came with all the AI already hooked up. So we had a fully functional town with just an art pass needed. We could always do a little bit of editing afterwards if we need to remove a building or add a new building, but in general, it was very flexible. So this one I'm going to skip very quickly over. This was our sound system. We also calculated out how our sounds worked based on what biome it was in, what props were around it. And that was done by another artist who talked with our sound designer. And then we had event spawners as well. So this is for, say, if we wanted to spawn some trucks broken down next to roads, groups of rebels in fields. And this allowed us to speed up our performance because all of these were pre-computed. So we could just call them if the player was nearby. So I want to look at a couple of tool types, tool archetypes. Basically, what is Houdini good at? Well, in terms of what we do, it allows you to automate tedious tasks and you get consistent results in return, right? You can speed up your production through rapid and evolving iterations, so you can keep building the same thing over and over until you're happy with it and you don't have to do it by hand. You have a high level of design flexibility, basically. Also, you can analyze and process large amounts of bulk data, which you can then turn into usable data for either other artists or for yourself. And well, it allows us to put tool design in the hands of artists, because many of the people in our team were actually hybrid artists or maybe a programmer. But the idea is that you can then hybridize it with Houdini and work in both fields. So as for the types of factors to tool design, first, let's say we have level of control. So level of control could be either a fully automated tool, or on the other hand, you have a tool that's mostly for manual design. So you use it by hand. You have user skill levels. So the user that's supposed to use the tool, either we use a technical artist or a trained artist, or is this a tool that's simple enough that you can just hand off to someone, right? That's a factor. Another factor is tool complexity. So small procedural assets versus large scale tool sets, right? And that kind of pairs with the production time. So it could either be a few days to produce or several months. And you kind of have to plan for that. Then we have tool performance. If it's an interactive tool, meaning the feedback is almost instant. If you have very fast feedback, maybe a few seconds, or if it takes a very long time, like it could be 10 minutes, 30 minutes. Though preferably you don't want to make your tools take that long to cook. I think 15 minutes, even on a render farm, is already a long time. And then you have an impact on the pipeline. So how much is the tool's capacity to boost your productivity, right? And then a couple of other factors. Maintenance friendliness is important. You know, being able to read your code and then share it with other people so they can understand it allows you to maintain your tool set for much longer. And also interconnectivity. So if a tool can get metadata from other tools, or if you have a tool set, that's very useful. So a couple of the archetypes I want to talk about here. We have canned assets. I dub them like that, but the idea is that they're standalone plug-and-play tools. You drop them down, they usually have a simple interface, and you just run with them. Processors, they're large-scale tools. Usually they're heavier, they take a lot more time to cook, but in general, you don't have as many controls on them. You can just run them on a render machine. Then we have editors. They're basically a combination of different types of tools with an interactive workflow, and they benefit a lot from cached data. I'll talk more about that. And then we have utilities. So utilities are these simpler, robust assets. They usually are part of your tool sets, like they simplify things. I'll explain more about these step by step. But basically, you can also combine them. So if you make your tools work together, you can use them as sub-assets. So you have a larger asset, and then you put the smaller ones inside and let the larger asset drive that. For example, let's say you build a road and then you automatically wanted to place power lines next to it. You could technically build the power line system into the road tool and make it do that afterwards. But you can still have the power line system separate, right? And then batch jobs means that you make the larger tool run the smaller tools in a batch. So maybe you want random results, you want a lot of them, or you just need to process a lot of different tiles and you just run per tile. That's one way. Then we have sequences. So this one is when you run things on a render farm and you set them up in a sequence. Pretty straightforward. You start it, maybe you can run it on a timer. And then we have loaders. So loaders is where you have two separate assets, but they share cached data. One asset may request something. You can then use the other asset to build it, and then you can load it back in as lightweight cached data. So instead of cooking it live, you basically load it in. And like I said, everything benefits from metadata. So metadata means you have stuff either stored on your game engine files or on a server. And this allows you to create interactive workflows. So some general statistics here about canned assets. Generally, you use curve inputs, parameter-driven inputs, maybe terrain you can plug into them, depending on what you need them for. They're easy to use because they tend to be smaller and they tend to be artist friendly to to build as well. Tool production time is pretty fast because they tend to have limited complexity. They tend to do one thing. Tool performance, again, they should be pretty fast and interactive. And they can speed up tasks, but they probably have a limited impact on your pipeline. That said, you can also use them as a fire and forget tool to output generated content, so basically bake out your data. Or you can keep them around with inputs, and then you can just regenerate them when necessary. So if you need to regenerate, say, the roads or rocks next to roads, for example, you can do that. So in this case, we had a couple of these tools, quite a lot of them actually. Here's one where we had vegetation. So we had a big vegetation tool which would automate vegetation across the world. But then sometimes designers also wanted to create local vegetation. And this is one example of that. Then we had the bridges and the tunnels. So those would hook into the roads. And they also included a standalone tool. So we could just manually draw a bridge somewhere. And if it was actually near a road, it could also hook into that road curve from the cache. So yeah, we had that control if we wanted to. And here's that railroad again. And then we had some power lines as well. Now power lines basically are just a lot of dynamic cable actors, and they connect between meshes, right? But they need to connect at very specific locations on the power line poles, and that's a lot of work. So by automating it, we just had to draw a little line, or maybe just say, I want a power line along this road, and it would place power poles for you and connect them with wires, and everything was hooked up. So for example, with this. Then next we had the processors. Now, processors are, like I said, tools that run by themselves. They're often data driven. You provide them some data and then they run. And they often also have fixed parameters unless you drive them from some other data file like a CSV data or text file. In general, they're managed by the technical artists, but they can be triggered by the artists themselves. So there's a mixed skill level there. So once an artist triggers it, they don't have to worry about it. It will just run, assuming everything goes well. They get the data back, right? And then as for tool complexity, they can be very complex, which means they can take a lot of time to develop. They can be slow, but optimization is still important. You don't want them to take too much time, otherwise they'll hog up your render farm. And in general, they can have a major impact on your pipeline or your content generation if necessary. Because in Wildlands, for example, we had this run every evening and it would just recompute everything. So in the morning, all of our procedural layers were up to date. It's very powerful. So again, like I mentioned, we used it for props. So in this case, we would take all the different props that were generated either by tools or placed by hand, and then we could balance them against one another to make sure we didn't have anything stick inside itself or stick like a tree into a rock. Then we got our roads, like I said. In this case, the processor would output this preview, like I shown before. So it's useful to get an immediate result 30 seconds later without having to cook it on your own system. And it keeps the world playable as well, because in some cases you could use this to detect if roads were disconnected, which might happen if a user wasn't careful. Right. And then here we had the tile terraforming, so the compositor. This one ran twice per day on a schedule, but we could also use it if we needed to by hand, rerun it by hand, or every time someone cooked out something like a road or a village or a farm field, it would also cook automatically after those tasks. So once you made a change to the terraforming, you needed to run the compositor, and the farm would do that automatically. Now, as for editors, so these are my favorite. Basically, they're very flexible. Their user skill level can also be artist friendly because they can be made very intuitive if built right, but they can also be very complex. So it's actually a good balance actually. Now, as for the production time, because of this added layer of interactivity, they can be more involved to create, so it can take longer to build. Performance is generally very fast because it needs to be for user feedback, though the backend, like the processor that runs behind it, can take longer, right? The interactive part needs to be fast, the feedback to the user, but whatever comes after can be more involved. In general, I think these have a high level of creative control and they allow for very fast editing. The only downside I would say is that you're relying on manually crafted cached data, so it takes more time to reuse the tool if your data changes, if you need to make a change to whatever you've created, than just running it on auto on a render farm and just having it do on its own. So you kind of need to compensate for that. So you need to be able to include, say, auto corrections, so you can easily fix results without having to spend too much time on it. So yeah, in this case, another editor, like I mentioned, the road builder, so I already went over that. And then we had the village tool. And in this case, the village tool was actually a sort of hybrid between a giant canned asset and an editor. It had a lot of input curves, but it also used these CSV tables for placement rules and also for sequences of rules and presets to build the town. So like I mentioned, we had buildings placed in order. That order was a CSV table that we could then load. And just to give you an idea, a CSV table is like an Excel sheet, right? It's like a JSON file. It's just a text document that comes in tables. And this is how buildings in the town were placed. And then we could also save out those presets, those CSV data strings. So we could have an external editor. Let's see. So here. This is an external editor that we could use. And this editor allowed artists outside of our technical artist team to manipulate the town how they wanted it. And then when we created the town, we could use that to quickly preset the tool, craft a particular shape of town, particular size, certain layout of objects. Plus, you might have noticed that we had these different districts. So they would give me this picture, for example, and then I would craft a town to look like that. And then as for utilities, utilities are, like I mentioned, these small little tools. They're often a separate category. They're very important to your pipeline. It allows, for example, importing and exporting of data that's not facilitated by the Houdini engine, so it's part of that pipeline. They can also be little subcomponents in your tools. So in your pipeline, they help your technical artists to create your tools faster. And in general, they speed up our tool creation pipeline. So usually they're only used by TAs, but they make our tool creation a lot faster because we can just share our resources and update them if we need to. So a couple of those. One of them was the fetch terrain. This was a utility asset that could load any map from our NOS. So again, height maps, terrain texture, sunlight exposure, hand paint layers, any of that. We just need to make sure we didn't load too many at a time because it could be heavy for well, the memory of your PC. But still, it's never wrong to have too much data available. Then we had the read mesh and the world reading. So in this case, we could get this cloud of data from the game engine where all the meshes in the world were located. Transforms, object IDs, what tile they were on. And then we could also load on top of those, using the read mesh from the game engine again, the meshes from our asset library, which could also include data like these these little red planes, for example, and they would be used by the village building tool to make sure that the terrain was always level with these parts of the building. And then finally, we can use them for debug and analysis. So in this case, think about finding terrain issues, terraforming issues. You can use it to detect overlapping props, if they were overlapping roads, for example, and then you can get a feedback in the world like that, or to detect disconnections of the road network. So that's the part about Ghost Recon Wildlands. And yeah, if you're still interested in the game, it's a very good game, I think, personally, and I love playing it myself. But then here, let's go into transition into the masterclass portion. So in this case, I started actually, like I mentioned, at Ubisoft. I created this masterclass, 35 hours, and it was shared by about 400 of my colleagues, and they were the students basically, and yeah, they would either partially or completely follow it, right? So it was this little town builder with some roads, basically the same system that we kind of used in Ghost Recon Wildlands, but just, you know, compressed down. And then one of my students, Christian Marzi, he put up a video on YouTube of his project, and he added some of his own terrain and rivers, and then imported it into Unreal, which looked pretty good. This is from his video, actually. And then let's talk about my own masterclass. So from here, over the last few years, in my spare time, I've been working on my own Houdini Masterclass, which is a much higher production value video series. And here I'm going to explain to you what I'm trying to build with this course. Then I'll go over how its pipeline is constructed. And then finally we'll go over how you can get some resources to start learning yourself. So let's dive in. Right, and I just have to say, it is a work in progress. So, well, basically it's just me in this case. It's a team of one, but it's a tool set that's going to be designed for smaller teams. Next to that, the audience is a hybrid between game development and architectural visualization. It's not really one of the other, but I'm building it in Unreal, so it can be useful for either one. And the goal is to save a lot of time and accelerate production of, say, repeated tasks using assets. Now, as for the toolset itself, I have about 15 different tools. Then I have 60 assets or utility assets. And I'm also using several sets of metadata and CSV caches as well in the later parts of the course. Actually goes from beginner level all the way up to master. So over here is the first tool. This is the building drawing tool. And this tool, well, its goal is to help design procedural structures. And its target user is for artists who can then use it in either Houdini or the Unreal Engine to design buildings. Now it supports multiple tile sets, as you can see here. It will also support an interior layout for corridors, rooms. You can create customized atrium spaces, and it also has elevators and staircases so you can traverse it vertically. And then finally, the last tool in the tool set that it's going to hook up to is the interior decoration tool set. So with this you can then decorate the building with furniture and other decorations. So here's a little video about the first tool, and it's currently a work in progress, but yeah, I'll let it speak for itself. So yeah, the idea is that you can draw the building with a brush. In this case I'm using a curve in Unreal, and I can save out the results. You can also use it to remove sections from it, basically cut out a section. And then once you've drawn your layers, you can start adding styles as well. So here I'm adding a different style for the outside facade, or the top. Here I'm drawing some internal corridors. They can also have a style and a height as well. And then finally, once you've drawn all these, you can then add your staircase in this case, which should hook up to the nearby corridor so you can access it. And here I'm adding an elevator. And then you can just output the results. So here's the output. You can then go ahead back and tweak things because it's still an editor. Here I'm adding a change to the outside, and here I'm just adding a couple of changes to the internal corridors. And then you can go in and playtest it. So it's fully traversable. I've got rooms in there. I've got these staircases in this case. It's also built completely out of tile sets. So you can change out whatever tile set you want. And then, well, the idea is that this is going to come as a lecture set in 2022, so this next coming year. So the idea for this is that each building has these horizontal slices, basically. Inside of it, you have the layouts of the rooms and the corridors and everything. Next to that, you can also see that the building is built out of layers, and that each of those layers has their own internal layout. So here's a little view of that, where if you take the building and you just look at the different modes of the tool, you can see the inside. There's all the corridors and elevators and the staircases, and they all fit in there. It's kind of like a layered cake. That was my goal. That's how buildings tend to be constructed, right? So for the outside facade, not complete yet, but the idea is that it will load tiles with much more detail. So it's basically just a tile set that you can assign. Now, like I mentioned, this part of the course is for intermediate students. It comes right after the introduction module, and I will be trying to release it in this next year. So parts 2 and 3, the elevator, staircase, and then the main building tool. Now, next to that, I also have the next part, which is this atrium designer. It allows you to create custom atriums, lobbies, and pools. As for the target user, again, it's for artists. And you can again use it in Houdini and the Unreal Engine if you want. Because it's going to use cached data, it's interchangeable actually. You could create an environment in either one and then load it in the other and then keep working. So here I have one of the cutouts of my building, and it creates this kind of representation of this environment. You can load it into the tool and use it to create, well, this atrium here. So it's fully interactable in this case. We have doors that open, we have the elevator in there, some staircases, catwalks as well, and even a pool. Though you can't swim in it yet. Now as for this part, so it's a hand-drawn procedural environment, which means that I have several tools in there that each allow you to do a particular thing. But basically we have this drawing tool. You can draw out the different components, and then it will run the tools on that, and it creates all the components for you, like railings, catwalks, stairs, elevators. So the drawing tool is the main input, and then the environment that it's built into, and you get that. So here's a couple of pictures, like the pool and some of the paths around it. That's done with a pathfinder and a width attribute. And here we have some planters, some small internal structures like this shop, and then some zones which you could maybe use as a terrace or something. So for this course we'll need a lot of data management. It also needs to integrate properly into an existing building, so it's more involved. Also do some advanced pathfinding as well for the catwalks. And in this case my goal is to release this around 2023 if all goes well. And then the last tool, the most advanced one, is a procedural internal environment decorator. Automates prop placement. And this one is actually a combination of art director or technical artists who create the presets for this environment. So you can basically lay out structure, the structure of your furniture, how you want your rooms to be built up. And then you can give it to an artist using those presets, and it allows them to then use simple drop downs to access your presets, and then the tool will run and place the objects. So you can see how this kitchen here, depending on where it's placed, gets a completely different shape because the objects inside of it have a relation to one another. And then finally, just to make sure that it's possible to make edits, I also have this manual editor, which is much more hands-on, uses Python viewer states, so you can drag objects around, add new ones, with a simple interface and mouse and keyboard commands. So yeah. And in this case, let me quickly show you how the tool actually works. So we have objects that are spawned one after the other, and they look for the environment and their neighbors. And they also have a pathing system as well. So if an object needs the player to be able to reach it, then it will ask for a path to the nearest exit, of the room, and other objects cannot obstruct that path. Or at least, if ever an object completely obstructs another object, it will not allow it to be placed there, so it will try to find a different spot. And we can use this to create partial presets or complete layouts for entire rooms. So this is just the kitchen. Now it may take a few seconds to compute, or a few minutes if you want to create an entire room. That's why it's very useful to run this, for example, on a processor and then output it using a render farm to a loader. Though it's still pretty fast. Here you can see if you use the interactive workflow, you only place a couple of objects at a time. I can draw a curve and then make it spawn there, and then I can save it out. So once I click the save button, it's stored in the cache, and then I can continue editing. Or you can run it on full auto, which basically just runs one sequence after the other. You can add pieces one by one, or you can load an entire room at once, let it cook, and then you can save it to a cache, and then, well, instant hotel room, basically. Now to facilitate this, I created my own form of smart props. This is all done in Houdini. It contains static meshes, decals, and Unreal blueprints. Plus they also contain these markers, these little objects, which are used to pre-analyze the shape. Like it's a bounding box, it's convex bounding shape, so they don't overlap one another, right? So you can have objects that aren't quite square, but still don't overlap. And then this comes with its own editor. So as you can see, I can grab objects around, I can move them, add them, even add them to different layers. So there's a random element to a smart prop. One object might have a different set of objects in it, like a bookcase might have different elements when it's spawned. And all this data is then stored in basically a CSV string. So it's kind of like I mentioned, it's like a spreadsheet. It's a good way to store data, and Houdini can both read and write it. Now, I created my own asset to compress this data down into a very long string and then unpack it again. But once the tool was created, it's very easy. You just give it data, it will compact it, and then you give it data back as a compacted string, and it unpacks it. So well, here's a demo space. This demo space has about 500 different props in it, little objects, big objects. There's about 300 smart props in there that I have in my data set. And it's driven by maybe about 50 different CSV presets, though you could potentially just bring it down to maybe one per room, right? Now this is definitely master level. I mean, it deals with a lot of advanced code. We have encoding CSV data in there as presets. Then there's the Python code as well for the viewer states. That's not something you can run in the Houdini engine, at least at this time. It's only compatible in Houdini. But then the tools are very useful for, say, standard artists when they're completed, because they just have to use the drop-downs. So the idea is that this is going to be released probably at the end of 2023, more likely 2024, because it's a lot to record. So just a quick overview. This is for the editing tool. I already showed a bit of this, but the idea is that you can just grab objects in the scene once they're placed and move them around, and yeah, you're pretty much free to do with what you want if you use the manual editing tool, and it all gets written back to the same cache when you save it, so you can just load it back into the automated decorating tool, and it will take into account what's already there. So if you want to add a new set of pictures on your walls, it will already take into account what's already there and not overlap them. So as for the pipeline, I'll try to go over that quickly. So here I'm going to show you how they fit together. So first we have the building tool. This asset is the core tool of the entire project, and it can load and combine the cache data from all the other assets. It can also run them, at least partially, as say subcomponents. Next to that, we have the atrium toolset. Now, like I mentioned, this one's going to grab the atrium environments that you can draw in the building. It's going to get them as cache data, and then we can design our own environment and then send it back in a loader. And then finally, we have the interior props. So this one is either the auto processor. Let's say you've built all these hotel rooms. You can tell it which floor you want to add detail to. It will already have assigned what detail it wants to load, and then it runs the processor over that, perhaps on a render farm, if by that time I've set that up. And then you can also use the manual tool as well if you want, so you can edit that afterwards. Now in this case, for the building tool itself, it actually contains several editor sub-assets. So we have a drawing tool, we have a pathing tool for the corridors, and then we have a prefab slot system. So you can load in these prefab assets like the staircase, the elevator and such. So in this case, that's what I have here. It also configures them properly. So depending on the height of the floor or maybe the height of the building, right? How many levels you have, it will configure the elevator or the staircase. Then on the right, once the building is drawn, I have this analysis processor, which is going to take the building and basically break it down, analyze corners, if it's a landing, if there's different zones in the building, and then it can analyze all that data and then break it down for the other tools to use. So we have the tile instancer, which is used to create the outside tiles and the inside tiles for the building, for both the interior and the exterior. And we have the railing tool over here, which creates railings on the sides of, like, for example, a balustrade, right? A balcony. And then we can also send the data from the prefabs to the atrium tool. So we can then load that back in. And finally, we can also send out data from the props back into the tool. Then for the atrium tool, in this case, I have even more editors. In this case, I've also added a catwalk tool. So let's quickly over that. First, we can draw the floors and the rooms in the building using the drawing tool. We can also add these elements like the pool and the planter. The staircase and the elevators make a return. And then we also have the catwalks, and these use a advanced pathfinder. So that's a separate tool on its own. And if you combine all of that, you can then again analyze it all. In this case, again, I'm placing tiles and railings. And then we can take that as well and run props over it if we want to. And then when you're done, you save it out, and then the main tool can load it. So you have this completely finished environment that you can load back into the main tool set. Now, as for the final tool, the interior props, in this case, it's completely interchangeable. Like I said, they use the same cache. You could start here and then continue there, or switch between them. They use the environment, or whatever environment you give it. The idea is that this is going to be a preparation tool for your data. It prepares everything and then sends it to these guys. I could easily build this one into these tools if I needed to as a sub-asset. So the automated system allows me to build entire rooms out, and then the manual system allows me to tweak it. Next to that, they use a lot of CSV data. So like I mentioned, each object has its own placement rules, and then they have their own way how they should be assembled. So maybe this object first, then that object, and that object. And this is all, again, encoded into CSV data. Quite advanced stuff, this, but once you understand it, you can do a lot with it. And then for the smart props, so the smaller objects, the individual components that I'm placing, they also get stored in CSV data, and these can also read that. And there's this editor for that. And again, once you're done, you just send it out to a loader, and you can load it in anywhere. Unreal, another Houdini tool, whatever. Now, one last thing I want to go over here before we do the last chapter. This is about easing some of your own tasks, right? So in this case, I had to create this side utility because I had about 500 different props that I had to prepare. Now, these all came from BlenderKit, which is a royalty-free open license asset database, which is quite beneficial for me because I want to be able to provide these with my course, right? But these assets were completely incompatible with Unreal. They often contained terrible poly counts, dozens of extremely high resolution textures, and sometimes no textures at all, like they were just procedural Blender textures. So I needed to actually convert all of that. I had to convert the meshes, de-res them, sometimes re-UV them, and add collision. And I had to do that for about 500 different models for different styles of rooms and everything. Lots of work. So I created a procedural tool that helped assist me in this. And as a result, I was able to do it in less than 3 months' time, in my spare time, mind you. I still have a day job, so I do all of this stuff in the evenings and the weekends. It was still a lot of work, but basically this tool allowed me to take my meshes, reassign the materials, maybe change the topology a bit, de-res them, and then fix the UV layout. And it allowed me to also optimize my texture space. So very easy. Then I could also use it to create texture atlases for multiple objects at a time to save on texture space. In this case, I could output it as a 1K or 4K texture. And with that, I was able to create all of these. And then finally, I just quickly want to talk about how to get up to speed with Houdini. So, almost done. Now the point is, everyone does learn in their own way, and I can't really stop you from doing that, right? I'm not trying to. However, I do believe that the best way to learn is to start with a solid foundation. And that basically means that if you're trying to learn Houdini, it's a completely different type of software than any other 3D software. It's not like Maya or Max. I should probably understand at this point. So it's very important to understand some of the core principles, like how node flow works in Houdini, how geometry is handled, and how data such as groups and attributes exist inside geometry. So those are some of the core things you need to know. And for that, I actually created a video lecture series on YouTube under my channel, E-Houdini Academy. And it's about 7 hours long. It's 11 videos. It goes into the basics of Houdini, gives you a solid understanding. You can find it there. And as for the types of things we go into, there's procedural node flow, groups and attributes. We cover expressions, some basic concepts around VEX. We cover what a Houdini digital asset is and the types of Houdini digital assets that we will be using in the course, object and sub level. And then also how you can combine it with the Unreal Engine, like how you can use the Houdini engine in Unreal. And then next, I think it's important that you start learning puzzle pieces. So Houdini is basically a giant puzzle box, lots of pieces you can use. I don't think anyone really knows. The only person that I know that knows probably the majority of them is Jeff Wagner, and he works at Side Effects for probably as long as Side Effects exists at this point. Great guy, by the way. You can talk quite a lot with him. But basically, if you know these puzzle pieces, then you can build better tools, right? Knowing more means you have more capability to think outside the box. So it's always good to learn as many as possible. And for that, you can start with small form tutorials, or you can use them to expand your knowledge. They often focus on a specific subset, and there's a lot of them. You can find them on the sideeffects.com/tutorials page. However, they also often only teach you a very limited set of nodes, and they focus on a very specific subject. So for a new user, I actually think that it's a good idea to go into a full project course instead, because this allows you to grasp the thinking process that goes on behind tool design and how to avoid the pitfalls that you might otherwise encounter, because those can actually trip you up. So for that, I actually created a free foundation course. Again, in this case, it's a 35-hour course. It's about 30 videos long. I'm just about to finish the last video. It will come in the next week or so. And here's a little trailer for that one. So yeah, hope you enjoyed that one. Basically, we'll cover in this course common nodes and their usage, Houdini digital assets for the Unreal Engine, utility assets as well. We're building 3 different smaller assets to help us construct this building, to keep objects apart on the roof, for example, or to texture the exterior, or the entire building actually. We're going to do 3D procedural modeling. We'll deal with instancing and also Unreal mesh generation, so actually creating our own meshes and then instancing those. We'll deal with procedural UVing and materials, some of the basics. Tool optimization as well, so how we can actually make this tool faster, how we can use some compiled networks. And finally, we'll deal with user feedback through visualizers, like these colorful elements you see on the building. They're useful to give your user the information he needs to use the tool. So, like I mentioned, so far I finished the first module of the masterclass. We have Houdini 101 and the foundation course. So you can build these types of buildings. They're very simple mesh-based buildings. And then after that, module 2 and 2 to 6 are going to be released. I'm thinking about a patron backer model, where if you get a certain tier of the patron backers, or if you've been a long-term backer, you get access to these courses. And then later I'll also release them on a learning platform when I finish them. But there will be more free content on my YouTube channel as well, periodically. So if you sign up to that one, you'll find it there. And you can get started on the course now at E-Houdini Academy on my YouTube channel. Or if you want to learn more about the course, there is my website as well. So you can go there. Now, as for my community, I have a Discord community. There's about 200 people right now that are in there that are interested in Houdini and talking about it. So feel free to join. If you want to, I can give you the link in person in a minute. Or you can join my Twitter, though I tend to post way more in my Discord, just to say. And finally, a little bit of a plug here. Frankly, this masterclass wouldn't be possible without my patron backers. So if you were to become a patron, you get daily and weekly updates on the progress on the course, when I develop it, and when I release new videos. People that back me for a long time, they get discount credits as well for upcoming modules. And finally, I also provide mentoring and student guidance on my Discord as a patron tier. And for non-game company related companies, I can also provide some consulting. So that's there as well if you're interested. So for that, you can contact me, or you can go to my Patreon page at patreon.com Erwin Heyms. So that's, yeah, thank you for watching this presentation. And if there's any questions at this point.
Okay, first off, thank you, Erwin. I want to start by saying, I mean, me and Hans were talking just now that we think it's like super essential for future TAs and Houdini artists to learn like the complex systems that you show here, because because that's what you're doing if you're working in a bigger company.
I'm trying to show behind the curtain,
yeah,
how you actually build these types of toolset, what the mindset is, and how to think of it in large scale as well, not just a single project that looks pretty, but how you build something as a whole. And that's the entire goal behind the masterclass and why I'm focusing on pipelines.
Mm-hmm. That's yeah, that was, I just wanted to highlight that as well. Yeah, indeed. I'm gonna ask you a question that I don't know if you're yes, there's some, if you're allowed to answer. So during Ghost Recon, you made loads of parts of the world procedurally. Yeah. Were there any pitfalls in making, like, let's say, too much between quotes of it procedural, or was it never really an issue for this case?
Not to go into too much detail, but there have been times where I built my tools. Like I mentioned how I said the village builder was a large canned asset with an editor component. I did try to upgrade it to an editor, but it's only useful if your artists like want to use it, or if the design is very specific when you want to use such a tool. Maybe you'll spend more time using the tool if it's really customizable. Like you really need to create you curate your tools for a solution. If that solution is creating a large amount of content procedurally, then you're fine. If your solution is, I want to kind of do what someone does manually, then maybe consider if it's necessary, like what's the benefit? Does the village builder in this case add AI, for example? Does it deal with hooking things up that you might have to do by hand? That's going to take a lot of time. Or is it better maybe to create a smaller tool that does those little tasks for you and skip the bigger tool? So you have to think about the purpose and is it going to be useful to go there. But in general, if you have a lot of work to do and it's repetitive, like I said, or if it takes a lot of time, then you can use proceduralism to either speed you through the process, if it's more manual, or if it's automated, then you can make it run for you, right?
Okay, thank you. You also mentioned something about sound system also. Yeah. We have currently like a sound major within DIA. So that's a new. Is there like more information somewhere about this that students could access, or is that?
You can try to check if maybe Benoit's Hive presentation has a bit more information about it. We have talked about this a bit, but in general, what we did is, like I said, we had a bit of a bottleneck there, and we needed to just be able to have all the information. So I think one of my colleagues sat down, Twan de Graaf, he sat down with the sound designer at the time, and they hashed out this way to create a little spreadsheet of basically computations of comparisons of this zone with this condition creates this sound, and then he did some blending to make sure the maps weren't too random, so you wouldn't just walk from one sound into the other. It would have more of the major sounds would take over the smaller sounds, so you created more of a blending between everything. So there was definitely some processing involved, and then the setup itself was set up kind of by design from the sound designer. They worked this out between them, and it worked pretty well for them. And frankly, since our team was so small, we didn't have to share it with too many people. So once it worked, and it was automated at that point. We ran it on the farm every so often.
Okay, thank you. I see that there's another question here from Kate. What are the possibilities for manual changes for artists? After all, procedural stuff was done in big maps. And then a follow-up questions, is it updating, for instance, terrain, mass, and scatter, etc.? How to set up assets properly for such a pipeline? Right. It's quite a...
well, two questions. So the first one, well, let me answer the second one first, and then we come back to the first one, right, to remind me. So the part about setting up assets, it depends. Usually it's just about pivot points and scale, maybe LODs, right? But when it comes to, say, smart props, like assets with more data in them than just a mesh, maybe blueprints, right? They need to get certain information. They need to make sure that the tool can read that and load that. So if you want to use that, for example, in your tool set as something to drive placement or drive how it processes a mesh. So yeah, it does take some time. You do need to make sure your pipeline has that in mind. And then the first question was, again?
What are the possibilities for manual changes for artists after all the procedural stuff in the big maps?
Right. So one of the major things is we actually build our tool set step by step. And we ended up creating our content, a lot of it in pre-production, and then during production we were still adding our content, but at some point we had to start locking things down. And we didn't always do that. Sometimes we had to regenerate, but at some point we started to regenerate the roads a lot less and less because roads were very important. Then the railroads were locked down way before that, because if we moved the railroads, then the roads wouldn't line up, and then we had to recompute the roads. And if the roads were recomputed, then I don't know, the villages would have to be recomputed. So we actually created some kind of, how do you say that? Say if we had to move a road, then we could remove a section of the road where the village was, and then it would kind of blend the road to the village. So we did have that ability to kind of go back in the order in which things were supposed to go. But the main goal was, at some point you stop processing these tools, you lock that data down, it's fixed. And other things, for example, you could think of as the props themselves in the world, right? They were all recomputed over and over and over again, but we weren't recomputing, for example, what tree goes where. We would just snap it back to the ground. if maybe the terrain changed. And then if we needed to change the vegetation there, then we could do that maybe in a pass. But yeah, it's all about locking down your data, deciding when you're done with procedural layer, and making sure that everyone is on board with that. That's important. Because if you have to start adding roads once people have already placed a lot of stuff around, that's actually one of the reasons that I upgraded the toolset, because I needed more control over where roads would go, and otherwise they would have gone straight through someone's farmhouse or something. I needed to be able to see where people had hand painted, and in version 2 of the tool I could actually see as a black shape on my Houdini terrain, my representation. So I could avoid that as much as possible and keep it in the areas that people hadn't been working on.
Okay, I thank you. I think that was a complete answer to that question. I see there is another question in the chat. Is the animation for the presentation, between brackets, done in Houdini? If not, what software would you recommend to create a video walkthrough?
The GIF files that I have, I use screen to GIF, I think. Let's see. Yeah, screen to GIF. And it allows you to take snapshots. It allows you to just capture your screen and then edit your GIF files after, and even convert video files. And for the rest, I'm just using OBS to capture things. As for the animation in the slides, that's just PowerPoint. I don't do too much animation in Houdini. I know how to do it, but in general, I'm more world building focused, and so is my course in the end. The stuff in the game engine is all blueprints, right? So doors that open and such. So I made some blueprints for that, for the elevator and such.
Okay. Thank you for your talk. That was, I think, all the questions I can see right now. Maybe you can drop the link to your YouTube or your website in the chat. I think that might be interesting for the people here. And then I also want to thank you for your presentation. I found it really interesting.
Yeah, no problem. I'll drop some links here. I've got my website. I've got my Discord, so feel free to join that. There are patron-specific channels in the Discord, but there's also an open and free channel, and I tend to answer questions about Houdini there as well. And then for my patron, you can find it here. Oh, I'm texting it to you.
Yeah.
Sorry, I should send it to everyone.
I'm trying to send it to everyone. So that was the Discord, and that's the last link. Voilà. So that's it. Normally it will also be in the slides that you share with the participant afterwards, in case you haven't saved the links. Okay, then I think we will end our day here. Thank you very much, Erwin, for joining us.
Thank you for having me. It's always nice to talk about this stuff. Yeah.
And I think we will keep following you and see what you put out.
It's still a lot of work, let's put it that way. Recording the first module took me about 5 months in my own spare time, mind you. I'm not doing this even full time, so but it's definitely something I like to do. I like to interact with my students, and it's always good that they're supporting me as well. So there's this feedback, there's this interaction, and I frankly, I love it. All right.
Okay.
I think that's
thank you.
That's it. Thanks.
Now we'll end the webinar here.
Bye, everyone.
Bye-bye.